Now, the relation between effort and weight lowered by a screw jack, we have to understand that as earlier on discussed, now with the effort and weight lifted by screw, we use the maximum force that is that is required uh, to keep the body in equilibrium when it is just about slide upwards or it's about to move upwards on an inclined plane when this force is applied horizontally to the body. Now, in this scenario, we are looking at what if we are lowering the body down. So when we are lowering the body down using the screw jack, we are also going to uh, analyze this system by applying the other principle that the force now required to lower this screw down is equal to is going to be obtained by also monitoring or looking for the force that is analogous to the one applied on a body on an inclined plane when the force is horizontally and at the point of the body sliding downwards or down the inclined plane. And therefore, once we have understood that that force is now going to be applicable or is going to be applied at the mean radius of the screw, then we shall be able to apply the fact that the moment applied at the mean radius to lower the screw will equal to the moment applied at the end of the handle to lower down the load. And that will be our the end of our discussion because we will have been able to determine that force. So the force that is applicable, that is applied on a body horizontally on an inclined plane, when the body is just about slide downwards along the inclined plane, is this P. The P is W tan of alpha minus phi, and that is so if alpha is greater than phi, and P is W tan of phi minus alpha, and that is so when phi is greater than alpha. Now, what does that mean? So you'll say that the moment required about the mean radius of the screw to lower the screw down will equal to the moment of the effort stroke force applied at the end of the handle to lower down the load. This tells us that P times R will equal to P1 times L, whereby this is the length of the handle, and this P is the effort applied, effort stroke force applied. So this means that W tan of alpha minus phi, times R will equal to P1 times L. And therefore P1 will be WR tan of alpha minus phi, everything divided by L. And this will be the expression required by anyone to determine this effort or force applied at the end of the handle. Now, let us take an example on this same problem.